This will just be a very short little video introducing you to conic sections. Now I say introducing you, but you've actually seen conic sections before. You've studied circles and you've studied quadratic equations which give you parabolas. Both of those are conic sections. But let's talk about what a conic section is. Right in conic section we see the word cone, and that's why I've drawn this cone here. Conic sections are sections of cones, and so if we think about the ways in which we can slice a cone, well, we could slice that cone horizontally to the base of the cone. Horizontally, or rather parallel to the base of the cone. If we were to do that, what we would see is we would get a perfect circle. And so that is, like I said, probably one of the first conic sections you've ever studied without understanding really where it comes from. Now we see circles all over the place, but if we think about where that is coming from, it is just coming from a circle. So why is it important to realize that it's coming from a conic section? Well, as we go through this unit, we're going to see a lot of similarities between all of the conic sections, and so it's nice to be able to tie them together. And so the reason all those similarities exist is because they're all coming from that one unified shape, being a cone. And so we'll see these equations as we go through each video from here. We'll see how their equations have similarities, how they have differences, and we'll really understand them. But I just want to outline how we get to these shapes. The next conic section that I'm going to discuss is very much like a circle, but this time rather than cutting it perfectly parallel to the base, I'm going to cut it on a little bit of a diagonal. I'm going to cut it just like that. And so what we would see is it's not a perfect circle anymore because it's longer than it is wide. And so what that gives us is an ellipse. May have heard this or seen this as an oval back in kindergarten, but we're going to refer to it by its more formal name, an ellipse. So kind of have a lot of similar properties to the circle because again they're right next to each other. It's just taking that line and putting it a little bit of a diagonal, and we end up with this different shape. But then what happens when we escape the bottom? So what if I were to cut that cone so that it extends past the bottom, and it would extend out. Even if we were to extend this cone out, we would see that it is eventually breaking the circle at the bottom, or breaking its base. And so this shape's a little bit harder to see, but if we think about what the side would approach and then hitting the other edge and then going back down the other side, that shape is the parabola. Parabolas, again, you've studied before when you were looking at quadratic equations, but parabolas go beyond just quadratic equations. Parabolas can go up and down as you're used to seeing. They can also go left and right, and those are not functions, just like circles, ellipses, also not functions. But they're still a shape that we're going to study. They're important. It doesn't matter if something is a function or not. Functions have certain properties. Other shapes are still valuable. Then the last shape that we could have is the most abstract, because we're going to actually stack two cones on top of one another. I'm going to place another cone up here. Let me do it in black. So we'll have our other cone up here. And so if I were to cut through both cones at the same time, well, then we end up with these two almost parabolic looking regions. They are not parabolas. What that brings us to is something called a hyperbola. Now hyperbolas, like I said, almost look like they're facing like a parabola would, up and down. But the difference between them and the parabolas, let me try and draw it a little bit better even, is that they're now controlled by the edges of the cone. They cannot escape those edges. Even if we're to continue, cutting down, down, that cone we'd think about it extending out infinitely. It's never going to escape the edge, and so that means there's a controlling factor there. It's called an asymptote. So these ends are actually approaching the asymptotes and not just allowed to escape off to infinity like our parabola does. So even though they kind of have a similar looking form at first, because the hyperbola does approach those asymptotes, that we'll study how to find those, we're going to see that it is not the same as a parabola. There's a really nice site that I like www.intmath.com. They do a lot of nice demonstrations, but they do a really nice one in this conic section segment. And so you can visit that website, and this is just a little screenshot of the tool that they have available. You can play with these shapes. So for instance, you can see here they've chopped those two cones in the way that they would get an ellipse. They've chopped through just one of them. And so their drawings are significantly better than mine because it is a computer program. And it's a really nice, easy tool to use. You can move the plane around, you can move your positioning around, you can drag the shape around. So I would definitely recommend visiting this site and playing with their picture a little bit. It's a fun little tool and really gets you comfortable with the different conic sections. From here, now we're going to go in and really understand what are those conic sections in the following videos.